that works.
Oh my goodness, those were so exciting when they first came out.
It might not work.
Might not
They
work.
were so
Maybe
fun.
move it forward a little.
Yeah, maybe.
Yeah.
Oh. I don't think it's working.
Okay, so it's purple.
There's something to stay right here. Put your, put something here. I know you're covered. We need that shit. Dog, this ain't working. Hold up. There you go.
But then you also sharpened it.
Why are you making that noise?
Is that how you work on it? Hold on. Is that how you, what you do?
You need to record for Nathan. Yeah. Dude, your phone's gonna die before
And you got a better quiz?
Oh no, it doesn't fall over. Look at that. Oh no, it's falling over. It's falling over. Oh shit.
Okay, we are doing horizontal and vertical. So we're gonna do some describing like we did from our transformation unit. And then we're gonna apply it to trig. So let's describe these. If we're horizontal, vertical, and where we're going. So if I have sine and then x minus 30, what translation is that?
Good.
Horizontal translation, yep, 30 degrees right. So x minus 30, 30 degrees to the right. Sine x plus 2. So now plus 2 is on the end. So what was that one?
Vertical translation 2.
Vertical translation 2 units up. Now how about if I have x plus 60 degrees and then minus 1 on the end? Sun has both of them. Horizontal translation, 60 degrees. Which way?
Left.
Left.
Too good.
Yep. And then minus 1 on the end will be vertical translation, 1 unit. So because it's minus 1, we're going to go 1 unit down. Okay, and our last one, y minus 45. If I move the y minus 45, the 45 over, it'll be plus 45 on the end. So that'll be horizontal, 45 degrees right, and vertical, 45 degrees up. So it's just the same stuff from our transformation unit. Same idea, but instead of calling it horizontal translation, vertical translation, in trigonometry, we refer to them, horizontal translation is called a horizontal phase shift. So instead of calling it horizontal translation, we're now going to call it horizontal phase shift, or HPS for short, because horizontal phase shift is a lot of letters. Vertical translation is now called vertical displacement. VD for short. So horizontal phase shift and vertical displacement now. So let's do some more, just filling in the phase shift and the displacement. So given our graph, our equation, we're going to just say what the displacement is or in the phase shift. So it's kind of like doing that description that we just did, but putting it in a table. So sine x plus 5, does it has a phase shift? No, so there's none. How about vertical displacement? 5 up. So you just moved it 5 up. So that sine graph would just move 5 up. How about x minus pi over 4? Phase shift, pi over 4
Right.
to the right. Displacement, none. let's just put a line, none. Y plus pi equals sine x plus 3 pi over 2. So displacement, or sorry, phase shift, 3 pi over 2 to the left. And displacement will be pi, which way?
Down.
Down. So our general form of our equation is with the C and our D. Kind of like when we just did transformations. So phase shift will be C. In this case, it would go right. And then plus D would be D up. So the C value is our phase shift. D is your displacement.
That's a painful student, bro.
So here's a summary of everything now with our full equation. A sine B times x minus C plus D. And the same goes for cosine. So sine and cosine follow the same pattern. The A value again is the amplitude, max minus min divided by 2. Our period again is 360 over B, or 2 pi over B. Or remember, if you didn't have B, we found out B from going, B is 360 over period. So remember, we solved for B by going 360 over period, or 2 pi over period. So that's how we found B. C is your phase shift that we just looked at. And D is your vertical displacement. If you're given a graph and you have to figure out the equation and the vertical displacement, the formula for vertical displacement is max plus min divided by 2. So amplitude is max minus min, displacement is max plus min. And that's when you're given a graph that we have to find the displacement. We're gonna do that on the next couple pages. And then tangent summary. Tangent remember is special. Amplitude really doesn't matter because there's no max or min. There can be an A value. It's just saying if our graph is vertically stretched. Period is now 180 over B or pi over B. So remember, tangent is a different period. And then we still have our phase shift and our vertical displacement. So just a little summary there. The big thing is the change in the period compared to cosine and sine. They're different than the tangent one. So we're going to start off just practicing writing our equations. And then we're going to look at graphs. How do we get an equation from a graph? So cosine function, phase shift 75 degrees to the right. What will be the equation? 75 right, so that would be y equals cosine 75 right, x minus 75 degrees. That's it. How about a sine? Sine with a phase shift of 3 pi over 5 left and displacement of 4 units up. So 3 pi over 5 left and 4 up. What's the equation? Y equals sine, bracket, 3 pi over 5 left So x plus 3 pi over 5. And then 4 units up, plus 4. How were those? So those were just with phase shift and displacement. We didn't have the stretches in there yet. So now let's put all of it together. So we're given our equations. We're going to find the 4 things. Figure out the amplitude, the period, the phase shift, and the vertical displacement. So we're going to figure out all of the 4 values here for our new equations. Amplitude, period, phase shift, displacement. So, what is our amplitude? Amplitude is
2.
2. It's the number in the front. Period. How do we find period? Period is 2 pi over b. So our period in this case will be 2 pi over, our b value is 3. So 2 pi over 3. Phase shift, HPS. Phase shift. X plus pi, so it's going to be pi. Which direction?
Left.
Left. Pi left. And vertical displacement minus 4. So vertical displacement 4 down. So basically we're just taking those 4 values from our equation and just labeling them, saying what they are. Okay, let's try our cosine one. Negative 2/3 cosine 1/4 x minus pi over 12 plus 3. Amplitude. What is the amplitude?
2 over 3.
2 over 3. Remember, amplitude, it stays positive. The negative means it's a reflection. So our amplitude is just 2 over 3. The negative is for the reflection. Period. Period. 2 pi over b. Our b value is 1 over 4. So period is 2 pi. Divide 1 over 4. What does that equal?
8 pi.
2 divided by 1/4. 8 pi, right? 8 pi. Phase shift, HPS. Horizontal phase shift. X minus pi over 12, so pi over 12 to the right. And displacement, 3 units up. Yes.
Would we not state the reflection?
Nope, because they're just asking for those 4 things. Amplitude, period, phase shift, vertical displacement. If I was describing it, like if it said to describe, then I would say a reflection on the x-axis. Yeah. All right, our next 2 are different. Remember your transformation unit, when we were doing it, we needed our b value to be factored out. Like here we have 3 times x plus pi. Here it's 3x plus pi. So just like our transformation unit, we do have to factor out your p-value. So we have to factor out the 3. So it'd be really y equals 2 sine, factor out the 3. So we're left with x plus pi over 3, and then take away 4. So whenever your b value is not factored out, just like transformations, we have to factor it out, because that changes our phase shift. If we didn't, we think our phase shift went pi to the left, but it's actually pi over 3 to the left. So you do have to factor this b value. So what do we have? Amplitude. Amplitude is 2. Period. 2 pi over 3. Phase shift. Pi over 3 left. And vertical displacement 4 down. One more? One more. So again, our b value is not factored out. So once again, we have to factor out that b value. So it's really y equals negative cosine. Factor out the 2 x minus pi over 4 and plus pi on the end. So we do have to factor out the b values. So vertical displacement, no, why am I starting at vertical displacement? Amplitude. What's our amplitude? 1, right. Pretend 1 in the front. Period. 2 pi over 2, which is just really pi. Phase shift, HPS. Pi over 4, right? And displacement. Pi, which way? Don't we love it? It's very repetitive. Let's see if you love the graphs now. So that's getting all that stuff, pulling the information from the graph, or the equation. Now the fun begins, graphs.
What the hell was it, right?
So we're gonna come up with the graph of the equation for our graph. We are gonna do the same graph with a couple different variations. So we're gonna do a sine graph. And then a sine graph with a reflection. And then we're gonna do the same graph, but as a cosine graph. So we're gonna come up with different equations for these graphs. So we're given this graph, and notice we just have to find out A, the amplitude, and C. They gave us a big hint. We need to figure out A and the C. So A we need to know. A is the amplitude.
It's gonna be 4.
Max minus min divided by 2. What will be the A value?
4.
4 minus negative 4 over 2, it's 4. Our amplitude is 4. Our C value, C is your horizontal phase shift. So whenever we're doing graphs, it helps to picture what the original looks like. Our sine graph, the original sine graph always goes through the origin, and then it would start curving up. So our original sine graph would look like that. So notice our sine graph is shifted from the origin to the right there. We have to see how many units it has shifted right. So we have to see what our scale is. It's moved 2 units, but what is our x-axis split up into? So let's look at our scale. This is pi, that's 1 whole. What is it all split up into? 6. 1, 2, 3, 4, 5, 6. It's split up into 6. We've moved 2 of them, so we've moved 2 pi over 6. Because we've moved 2 units, so we moved 2 out of the 6. 2 out of 6 equals pi over.
Shit.
Our grid is split up into 6, and we moved over 2 of them. So our C value would be pi over 3. Right. So let's write our equation. Y equals 4 sine x minus pi over 3. So that's the equation for that graph. Yes.
This might be a really stupid question, but like, if it's negative already in the equation, like, you know, so, like, and it's already moving right, so, like.
Does it switch?
It's always negative.
Okay.
Like the general form, it's just like our tangent graph, or not tangent, trigonometry. The general form is always negative.
Okay.
Just like when we did transformations, how it was negative.
So then you wouldn't change it
Here.
unless it's
Yeah.
turning, then it's
If it goes left,
then it's gonna be positive.
then it's gonna be positive, right? Okay, let's try our next one. Don't worry, we have so many more to try. So now what if there's a reflection? What if our A is now gonna be negative and our graph reflects? So the normal sine graph starts at 0 and it goes up. If I want to reflect it, it starts at 0, the origin. So where will our graph go now if I'm gonna do the reflection? Instead of going up, it's gonna go down. So now we have to see how far it has moved. So notice this time, where would it have moved to for the reflection? It's gonna move to the left. Boom. It moved that way now. It's going towards the direction that would match the curve. So it's gonna move to here. How far has it moved? 1, 2, 3, 4 units. So it moved the 4 units. It's moved 4 pi out of the 6. So it's moved 4 of them out of 6, which is 2 pi over 3, reduces. So I went 2 pi over 3 to the left. So what's our equation? Y equals -4, because it's negative, the reflection. Sine x plus 2 pi over 3. Notice it also, right here is also like the same sort of shape, it going down. But whenever we're doing our left-right, we always want the minimum possible. So I always want to go to the closest matching spot. So it could have went right, but that's not minimal. That's even further away.
Wowzers.
Okay, let's see. We got more practice, don't worry. How about now if we have cosine? So it's exactly the same graph, but now we're going to do cosine. Cosine. Our A is still going to be 4. So our A is still going to be 4. Because it's still max minus min divide 2. But what will be our phase shift? Where did this graph go? So our sine graph always goes with the origin, starts with the origin. Where does cosine graph start?
1 to the right.
Not 1. Where's cosine graph? On
Zero.
the y-axis.
1 up.
Starts right at 1. But here it's going to start at 4 because we stretched it by 4.
What?
So cosine will start up here. Normally it's at 1, but we stretched it by 4. So it's going to go up right here. So we're going to move it from here to here. Because it's been multiplied by 4. So how far did it move?
5.
1, 2, 3, 4, 5 spaces. It moves 5 spaces. So it moved 5 pi out of the 6. And it moved towards the right. So our equation, y equals 4, cosine, x take away 5 pi over 6. The tricky part is definitely that horizontal phase shift. Finding the horizontal phase shift from your graph is the trickiest part. No, it is the trickiest though. Out of them all. Okay, let's try the next one. What if there's now the reflection? So instead of starting up here at positive 4, our graph will now go to negative 4. So down here. So we move from here to here. It didn't go very far. It didn't move that far. It moved 1 space, so it's moved 1 pi out of 6. It moved one of the spaces out of 6 to the left. So what will be the equation?
Y equals
Negative 4 cos
bracket x plus 5 or 6.
plus pi over 6.
It's worth
So notice the same curve could have 4 different equations. It will tell you which ones to do, if it wants cosine or if it wants positive or negative. So one simple curve could have 4 different answers. That is the tricky. Alright, let's do a couple more things.
Hope.
Oh yeah. So again, we have the same graph, but one we're gonna do with a sine answer, and one we'll do with cosine, because again, the same curve could have 4 different answers. So we're gonna do sine a greater than 0. Now we're gonna do everything. So now we're gonna have everything on it. So what is our amplitude? Max minus min divide by 2. 1 minus negative 5 over 2. 3. I'm going to skip to vertical displacement next, because it does help to know the vertical displacement before we figure out period and phase shift. What is our vertical displacement? Max plus min over 2. Negative 4. No. Negative 2. Vertical displacement, max plus min. What this negative 2 means is how far our graph has moved up or down. Vertical displacement is your new cut it in half middle line. So right here, negative 2. That's my new cut it in half middle line. It used to be at the x-axis, but now it's moved down too. So now let's figure out our period and our phase shift. Losing my voice. What is the period? 1 complete interval is to there. Period 4 pi. Phase shift. We're doing a sine graph. Sine graph always starts at the origin, but in this case, we moved our origin down 2 units. So it's not going to start here, sine graph. It's going to start down here because we moved our origin down 2 units. So sine graph would go up from there. So it moved 1 unit to the left. It moved to here. But what is our little grid split up into this time? 3. 1, 2, 3. It's split up in. It's split up into 3s. It's moved 1 of them. So it's moved pi over 3. Left. Each little graph would be split up into different units for our x-axis. I don't know. Okay, now we have to put this all together to the equation. What's the equation? Amplitude's the A. Phase shift is the C. Displacement is the D. We have to figure out the B value. Because remember, B value isn't just simply the period. Yeah. Because this graph, sine usually goes like here. The next spot closest is right there, like that move matches. It can't move to the right because that's too far. We always want minimum. We always want to move as close as we can as possible.
So you should always just do the minimum.
It's always the
Shut up,
minimum.
Mr. Roberts.
Always. It's not wrong if you went to the right, but it's not the minimum
Ross.
thing. Alright, so now let's figure out B, because we don't know B. We know period, but that's not what B is. What will B be?
Oh, what will be
B will be
2 pi
2 pi over period. 2 pi over 4 pi. So B will be 1/2. So now what's the equation? Now we can do it. Y equals 3 sine 1/2 x plus pi over 3 take away 2. Ugh.
We need to make it 1 for x plus pi over 3 then factor. We have to do that.
Okay, part B though. What if I throw the reflection on ya? What if A is less than 0? What if there's the reflection? The only thing that will change is our phase shift. So the only thing we have to figure out is our phase shift. Everything else will stay the same, but now our phase shift will be different. So if I want to do the reflection, instead of curving up, it's going to be going down. So it's gone from here to there. So instead of going right or left, it went right. How many units? 1, 2, 3, 4, 5 pi over 3. Because we said it was split up into 3's. It went to the right. So the only thing, if we make it a reflection, we have to change is the phase shift. So what do we got? Y equals -3 sine 1/2 x minus 5 pi over 3 take away 2. Yes, Benjamin.
Will our period,
Period's the same, because it's still the same graph.
will our period ever be reflected?
Oh,
Okay.
we only do reflection on the
On the
x-axis.
Pens. Do you know that?
Isn't this
You
really
bought
cool?
Ryan food.
Now you're not having any
Wait,
more
what?
fun
I bought
than
Ryan
me?
food pens.
Alright, let's do the same graph,
What is this question?
but what if it's cosine?
I bought
This one will
Ryan
be
food
quicker.
pens.
What if we do
Some of the
cosine
kindness in my
now?
heart. I hate you.
The only
They're
thing that'll
$15.
change, what's the only thing that'll change if we now make it cosine? Phase shift, right, because it's still the graph from before, so our amplitude is still free. Our period is still 4 pi. Our displacement is still -2, down 2. So our middle line is still at -2. The only thing that will change is your phase shift. So cosine doesn't start at the origin, it starts at the top of the graph. So in this case, it'll start up here. How much has it moved? 2 of them. 1, 2. So it's moved 2 pi over 3, right? It's nice when it's the same graph because the only thing you have to figure out is the phase shift. So y equals 3, cosine a half, because we found out the b value on the previous page was 1/2. X take away 2 pi over 3 minus 2. We're almost there. Almost. What if there's a reflection? Less than 0. Reflection. So our reflection would go down here. So it went from here to here. How much did it move? 1, 2, 3, 4 pi over 3 left. So y is negative 3 cosine half x plus 4 pi over 3 take away 2. I really do enjoy this stuff.
Oh, because
My lesson was 42 minutes long. 42 minutes.
that's not one.
The next unit is like you're gonna
I understood everything up until this point. Actually.
Hey Ben.
Oh, so that's all it is.
Ben, say hi to Nathan.
Hi Nathan. Oh, you're so like not to scare you, but like you're so good.
He has the lesson. I recorded the whole thing for him.
Oh, that's so nice. The life, dude.
Nathan never did that for me. I told him to record lessons. He never did.
That's so.
Notice we didn't do tangent. We don't really do the tan graph. We focus more sine cosine. So tangent, we don't really do too much with.
Show me that.
You might have to write like the odd equation, but we more focus sine cosine.
Okay. That's nice. Thank you.
You're welcome. You're gonna have a question in your homework with a tan graph.
You see my spot there?
But it is more focus on sine.
They gotta get out. You just haven't seen it.
Are you recording him because you think he's gonna get up?
Oh no, I was recording a lesson for Nathan.
Oh my god. Thank you, Michelle. I could have got some.
See,
0.5%.
0.5%. Calculate motivation. Pretty valid. Pretty valid.
Page, oh, there's no page, it's just numbers. Number 1,
Jason's not safe. Says no wheelchairs.
We're doing ACB.
I really gave us a little wheelchair.
Wait.
I respect it.
I wanna do B, D, F, PDF.
Number one.
Are you that type that does the homework while you're still doing the lesson? Nathan used to do
worst
it
time
all
I've
the
ever
time last.
Dude, I was writing while doing it.
Number 2. And then I would assign questions that he had already done, or I wouldn't assign those.
2.
It was funny.
You really are.
It sounds like you made that. It sounds like you
I'm sure something can send it, like an email, right?
Be careful.
email in this
Number
video.
3. Number
Can't you
3
just tell me which
starts
ones to do
here
so I can
for
end the video
A,
already?
and you're doing like reflection and non-reflection. 3 also goes to the next page, part B for cosine. People often forget this second part B, so don't forget part B continues, 3. Don't forget it. And then forget to do the cosine.
So that's all we're doing? 1, 2, 3?
That's it? No, it has been one.
Let's do,
Damn it.
let's do, what do you want to do? 4 or 5?
5.
5.
5.
The one's cosine.
No, me and Mark.
Actually, I wanna do 4. You can do 5 if you want for, you know. 6 is a tangent graph. You only have to figure out the B value and the C value though.
It's pretty easy peasy, lemon squeezy.
You can't footnote. It's not easy peasy lemon squeezy. I know for a damn fact. The moment you end that video, you're gonna go and fucking
That's
brick
it.
reels. I know that for a damn fact.
I'm feeling the math today.
Remember, the rest are there for extra practice. if you
Ben,
want.
come out here. Turn around, Ben.
Next day we do word
Let me
cloud,
catch a cheeky.
tiny photographs, and so
fire.
word cloud type stuff.
Nate will have a fire photo of them.
No, they're actually so good.
Kinda word cloud.
Wait, what the fuck is that? That's not me.
Sick on Monday.
That's not me.
Night quiz next Wednesday.